In this video, we'll show how to take a RayTK volume, convert it to a 3D texture, apply feedback, and then pull it back into RayTK to render as a cloud of color. We'll be starting up where we left off in the first part, so if you haven't watched that part, I recommend doing that first, but I also put that file up on Patreon if you want to skip ahead. If you're coming from the previous video, you may notice that I added a level top here just to increase the brightness and a reorder to set the background to be fully opaque, but other than that, it should be the same. You'll need to make sure to have the RayTK library loaded, as well as the RayTK Volumes add-on. You're also going to need to make sure to have the T3D library from Yosef Pelz's Patreon. There is a link to that in the video description. You can drag that T3D Talks file into anywhere in your project, and it's going to immediately hide itself, but you'll see this item in the top menu here that says T3D, and that means that it's loaded up. Once you have all the libraries loaded, we can get to building the scene. We're going to start with exporting the volume that we've defined into a 3D texture. Open the RayTK palette with Alt-R and create a texture 3D render. And then connect this SDF volume to its first input. Then create a null top coming out of the first output so you can see a preview of that 3D texture. Then take a look at the result, which you can do by right-clicking and choosing View. But I'm going to be looking at it in the side panel just to make things fit nicely in the recording. So you can zoom in a bit and see how we are seeing slices of that pattern that we have been rendering. What we're seeing in this first output here is the density for each spot in that three-dimensional grid that we're capturing in a texture here. We want to tell the renderer to capture an area that's big enough to include the whole shape. On the Texture 3D render, we can use the volume size parameter here to control how big of an area it's going to capture into that texture. You can use that to expand the area to make sure that you're capturing the whole thing. And when you're doing this, I find it helpful to zoom in and look at the sides and the top to make sure that those are fitting in. So if you go with a smaller size, you're going to see things getting cut off. Just make it smaller and smaller by increasing the size until everything fits into the frame. The exact values that you use are going to depend on how you set things up in the previous section, but at least for me, a value of 1.7 seems to be enough to fill the X and the Y part. With this shape, it's actually a bit shallower on the Z-axis than on the X and the Y, since it's based around a torus on the Z-axis. So we can take advantage of that by reducing the size of that axis. Ideally, we want to be capturing as small of an area as we can while still fitting the shape, with a bit of a margin since it's going to be moving around and changing shape a bit. When you're adjusting the Z-axis, pay attention in the preview to which slices it's appearing on. So as you decrease the size there, you're going to see it filling more and more of the slices until you go all the way out and then it's filling all of them. So you want to get it so that it's appearing in most of them, but not all. So for me, that's around 0.8. So there's still a little bit of padding in the first couple slices and the last couple slices in there. Next, we need to decide what resolution this texture should be. Keep in mind that 3D textures can take up a lot of GPU memory, so we should try to keep this from getting too large. It's also a good idea to save often in case things get messed up if you accidentally make that size too large and the GPU gets upset. Make sure to save your file, and then we'll take a look at the resolution. The default of 64 on all three axes is fairly low. We could probably get it to look okay at this resolution, but it would be nice to have it larger, especially since we're going to be adding some feedback trails and displacement. We can also make the Z resolution lower since it's covering less area on that axis. You can try setting this to something like 256, 256, and 128. See how the frame rate is, and this is going to depend on what GPU you have and what else is going on in your computer at the time. But if your frame rate is okay around there, you can try going higher. And these numbers don't necessarily have to be powers of 2. I just tend to like doing that, but you could make them to, maybe 300, 300, and 150 or something like that. Next, we'll set up the feedback loop that will produce trails off of this density volume. This part is going to be similar to the recent video about using RayTK with T3D. Drag out from this null top and create a feedback top. Then, coming out of that, add another null. And on the feedback parameter, drag the second null onto the target top parameter. Then open the regular op_create dialog with the tab key. And go over to the T3D section here. If you don't see this, that means that you haven't loaded up the T3D library. Switching over to that section, create a math operator. This is a special version of MathTop that works with 3D textures. And insert that between the feedback and this null here. On the multiply add page, decrease that multiply to around 0.9. This reduces the brightness of what's coming out of the feedback, which will help it fade out over time. Then create a T3D add operator. And we're going to connect that first null to the first input and the math to the second input. And then you can connect the output of that to our second null. Then if you take a look at the viewer for this second null, if you zoom in, you'll see how we're now getting these trails that are following things and fading out over time. Next, we'll add some noise displacement that's going to make things a bit more interesting. Create a T3D displace operator, and then create a T3D noise operator. Connect the feedback to the first input of the displace and the noise to the second input, and then connect that displace to the math. On the noise operator, go to the common page and set the pixel format to 32-bit float RGBA. It, I think, already defaults to that, but it's good to just be sure, and that's going to give us smoother displacement amounts. And also it's going to allow us to have negative numbers, which is going to be important. Then on the noise page, switch off that monochrome setting so that we get a different value for each axis. Then decrease the offset to 0. So this is going to make it produce values that are centered around 0 rather than centered around 0.5. And then decrease the amplitude down to around 0.1. Then on the displace, decrease the strength there to around 0.5. So now if you zoom in on the viewer here, you're going to see that things are creating these kind of warped trails that are based on that noise pattern there. The amplitude of the noise and the strength here get multiplied together, but I found it's useful to set the amplitude low on the noise so that we get a more useful range on the slider here rather than always having it, right by the low end. We can also increase the resolution on this noise on the common page, and that's going to smooth out that displacement pattern a bit. It doesn't necessarily have to match what we are using for that other texture that we're exporting, but it can be helpful to have it match. So if you want to have it match, you can go over to that texture 3D render, right-click its resolution parameter, choose copy parameter, and then go back over to your noise and right-click its resolution parameter, choose paste reference. To add some more motion to things, select this noise operator and open RayTK's Editor Tools menu with Alt-Shift-R. And under Animate with Speed, choose Translate. Then on the speed generator, you can adjust the different axes to have different speeds for the different axes, and then use this slider here to control the overall speed. So as you do that, you're going to see that things are moving and we get that displacement pattern moving. So pick some range that you like there and we can move on. Next, we'll take the data from the 3D texture and bring it back into RayTK to render. Open the RayTK palette with Alt-R and create a texture 3D volume. And then connect up that second null to its first input, the density texture input. This operator takes in one or more 3D textures and makes them available for RayTK operators to use as a volume. Next, we need to tell it what area this texture should fill. And this should match the area that we're capturing earlier in the pipeline. So go back over to your texture 3D render and take the volume size parameter, right-click that, choose copy parameter, then head back over to texture 3D volume and right-click its size parameter and choose paste reference. We could also do that for the center, but since it's at 0, then we don't really need to unless we plan on moving that. Now that we have a RayTK form of this volume, we can render it. And we can actually reuse the renderer that we had from the first part. Select the volumetric ray marks renderer, the noise field that's doing the ray offsetting, the linked camera, the camera viewport, and then any tops that you have at the end. And move those over. Then, instead of having this SDF volume connected directly to it, connect the texture 3D volume that we just created. Then if you take a look in the camera viewport, which you can do by right-clicking that and choosing View, but I'm going to be looking at it in the side panel just for recording purposes, you can take a look in there and try moving the view around and see how we're getting something that is similar to what we had before, but now we have all of that noise displacement being applied to it. You can also, on the camera viewport, go to the camera page here and click Reset Camera if things ended up in a weird state when you were working on it earlier. So now we're getting this cloud-style rendering of the contents of that 3D texture, but we're missing the color that we had in the previous version. Head back over to the texture 3D render that we're using to export earlier in the chain. And drag out of the second output and create a null. And this output produces the color. It's possible that the ordering of these might change in future versions, so just mouse over to make sure you're getting the right one. What we're seeing here, if you look in the viewer here, is the color property of that volume that we had set up in the first part. But if you zoom in, you may notice that this color is filling the entire area. What we're seeing here is the color of the original volume without the density applied to it to make those outside areas darker. The color of a volume and the density are two separate properties. We used a noise field to assign color to the volume, but that doesn't care at all about the density of the volume. It just fills the whole area with color. And it's up to the renderer to decide how to apply the density to that color. It's like this so that in future versions, it can support things like having a dense dark cloud in front of a brighter cloud. But at least for this scene, we can just use the color as it is and apply it to the volume after the conversion. It's not going to have the same feedback behavior that we set up here with the displacement, but at least for this scene, it should be okay to just use it as it is. If anyone has any suggestions for better ways to handle this, let me know. Now we can head back over to the texture 3D volume. In future versions of the toolkit, there's going to be a third input on this for color. So right now we're using the density input. There's also a surface distance input, which we aren't using for this scene, but at least in this version, it doesn't have a color input built into it. So if the version that you're using has that, you can just use that and skip the next part. But if not, like in the version here, we're going to have to do it ourselves. So open the RayTK palette with Alt-R and create an assign color. And insert that after the texture 3D volume. Then create a texture 3D field and connect that to the second input on the assign color. And then you can connect that color 3D texture to its input there. And then connect that assign color up to the renderer. So now if we head back over to our renderer, you can see that we are getting something in there, but the color looks kind of odd. The issue here is that we need to tell that texture 3D field what area it's supposed to be filling. And we need that to match the positioning of the volume. So head over to the texture 3D volume and then right click its size parameter, choose copy, and then on the texture 3D field, right click scale and choose paste expressions. So now it's going to fill the same area, whatever area we decide to capture in those settings in the texture 3D render earlier in the pipeline. One thing that you might notice as you move the view around is that there are these edges to it. So we're seeing here are the bounds of the 3D textures that we're using. Anything that is coming through those textures is going to get cut off at those points because there just aren't any pixels there that it can pull data from. In the feedback displacement, anytime that it pushes something outside of the bounds of the texture, it just gets lost because it kind of falls off the side. So then, to give ourselves a little bit more room, we can go over to the texture 3D render and just expand that volume size a bit. And since we're using expressions to control those corresponding settings on other operators, it should just work fine. But you may see things kind of briefly getting larger because we're having a feedback loop in there. But after a second, it should adjust back to normal. So now we have a larger area that this can fill. Head over to where we are taking this volume and pulling it back into RayTK from the 3D texture. We can insert lots of different kinds of filters between this and the renderer here. So open the palette and create a modulo 1D and set the axis to Z. And then just insert that after the assign color. Now if you move the view of the camera, you can see that we're getting that 1D repetition along one axis here. And it's going to keep going, I mean, in theory, infinitely, but the volumetric renderer has a limit on the bounds of the area that it can handle, which is in the settings on the renderer. So it's going to get cut off eventually, but you do still have some space to work with. And on the renderer, that setting is here with the area size. But within that space, we can do lots of different stuff. There are going to be some transforms that might cause errors if you try to insert them. I am working to get most of those updated to work better with volumes, but I recommend just trying stuff and seeing what works. And that's it. To recap, we are taking a volume from RayTK that we made in the previous video. We are exporting it to a 3D texture using this Texture 3D render. Then we are using some T3D operators to apply displacement and feedback to get those trails coming off of things. Then we are pulling that back into RayTK using a Texture 3D volume to take in the density data and then also the color. Then we are applying a transform filter to it here, modulo 1D. And then we are using the volumetric Volumetric render to render this in cloud mode. If you're watching this, you're probably already subscribed on Patreon, but if not, consider signing up. You'll get early tutorial access, exclusive downloads, Discord community access, and a bunch of other stuff. Thanks for watching, and make sure to like and subscribe.